In this video, we're going to talk about formatted printing and how to make sure that you get the correct data type into the print statement and out to the console so that you can have a usable output that makes sense for whatever it is that your program is trying to achieve. Okay, in this video, we're going to pick up where we left off after the assignment video, and we're going to talk about a little bit more where it comes to printing and formatting print, because I want you to have enough of a working base on that that you can comfortably go find out other things. But I just kind of want to make this a little bit clearer because one of the things with learning a new language is you kind of have to jump in order to to learn enough to use it, but then you really want to kind of refine what you know about that particular operation or type of coding that you're doing. So I want to spend a little bit of time on formatting print because I just think it'll make it a little bit faster for you. So I've closed down the last program we had and cleared our terminal. So I'm going to open up my template again, and I'm going to say File, Save As, and we're going to call this one Print. Okay, and actually I need to rename that. So I'm going to go rename print, print, PR, let's see if I can spell today, print.c. There we go. All right, and it picked it up here, print.c. Now I'm going to say this is going to be basic print formatting. All right, and here we are back at my template, which is kind of cool. So if you're worried about your templating, you can say Control C. Let's move my thing back to the right. Let's say make print. There it is. /print should virtually do nothing at all other than return a 0. All right, so now we know that my shell works. So let's jump right into it. I'm going to put some comments in here for you to use. All right, so printf uses a specific format. Okay, it is basically the %sign to tell you that the placeholder is coming. And then there's a position where you're going to put flags. And then there's a position where you're going to put the width of what you want the digits to be. And then there's a placeholder for dot precision, which is the number of decimal places you're going to want. And then the length. Okay? And that is the format that you should play with when you do these. Okay? That is what it looks like. Now, we've got flags, okay, and the flags look like this. If you use a minus as a flag, it basically means left justify the numbers, okay, and if you use a plus sign, it means force assign. And that's either going to be plus or minus. So notice this doesn't mean add or subtract. It means if it's minus, you're left justifying the number. If it's a plus sign as a flag, it means show the sign even if you wouldn't because it's just a plus sign or it's a positive number. You're not going to see the plus sign, but this says force it. Okay? And then there's another one. If you see a blank space, okay, that basically means do not show a sign. All right, and I'm going to just kind of see if I can get these to line up so they're nice and pretty. Okay, so those are the 3 flags you can use when you do it. All right, now I'm going to give you some of the common ones. Okay, a C delineates a character. And we've seen that once. We'll see that again. Okay, a D or I, and you can pretty much use those interchangeably. I just tend to use D, basically as a signed decimal integer. Okay, and then an F is a floating point number, and an S is a string of characters. Now there's others you can look up, but those are the basics. Now the next thing I'm going to show you is we talked about how you can use the ASCII value or the integer value of a letter. And that's cool. And so I want to show you that with a simple loop. I don't expect you to know what a for loop is yet. We've got a whole video on that. So don't worry so much about that. But I want to be able to print this out and show you what's going on with this. So just bear with me as I do this for loop. I'm going to start at an ASCII value of 65. And then I'm going to go until x is less than or equal to, we'll just go 100. We don't need to do the whole alphabet, and we're going to increase by 1. Okay, and we're going to say printf ASCII value colon %d, which is character, let's just say equal to %c/n, quote, comma, xx. And you'll notice, like I said in an earlier video, the variable x, which happens to be our index variable, is going to go from 65 to 100, and I can treat it as an integer or a character. Okay, so let's just save that, and let's see what we get with print. Okay, I got to scroll through this, but there you go. A, B, C, D, all the way through the end of the alphabet, and I get into the lowercase, because the little a is 97. I got one of the accents, I got an underscore, a caret, a right bracket, a left bracket, and a forward slash, okay? So if I kept going, I'd have gotten into the lowercase. All right, but that's basically the integer and the ASCII value. That's a lot of fun to play with at first, okay? The ones I want you to really know is that a capital A starts at 65 and a lowercase a starts at 97. If you know those two things and you get stuck on Mars, you know, you can rebuild what you need for the ASCII table, all right? So there you go. If you've seen The Martian, you know the reference I'm making. All right. Let's create a very long double. Long double. We'll call it FF. So we know that's how I kind of make my floating points. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5. Okay? So we got a really long double floating point. All right. Now, I'm going to do a series of print statements. So I'm going to say I'm printing different precisions. Okay. And what I'm going to do is I'm going to say printf. Here is a precision of 1, colon. And I'm going to say %.1 long float /n. And I have to put the variable in there, give it a semicolon, and I don't want to keep typing that. So I'm going to copy it. Whoops. Let's not erase it. And I'm going to paste it 1, 2, 3, 4, 5 times. All right, and we'll make this 2, 3, 4, and 5, just to make the point. All right, so let's try that. Save it. All my changes. Well, let's do a clear here. There we go. Make print. All right, so you can see at the bottom here, here's a precision of 1, 2, 3, 4, 5, and it didn't change. What's wrong with that? Let's go back and look at what we did. Oh, we copied it and we changed the output, but we never changed the precision. So you got to make sure that you change it where it actually matters, which is in the precision, okay? So this is going to be 0.4, and this is going to be 0.5. So now we've got it actually changed in the placeholder, not just our text. I cannot tell you how many times I've seen people beat themselves senseless because they didn't change it in the actual placeholder. Okay? And I do it all the time. All right, so we're going to make print ./print. And now you'll see we have the precision 1 place, 2 place, 3 place, 4 place, 5 place. Okay? Now, what I want you to notice is with the precision, okay, it gets to 1.234. This was 5, 6, so it rounded up, okay? So it is doing some rounding in there, okay? Because it's assuming the precision that we've told it to have. All right. Now, what if I were to do, if I were to change this to 6? Well, it would just go another decimal place, okay? So it doesn't matter the order. It's just you're going to get the precision. But what happens if I go past what I have? So let's say that I have 1, 2, 3, 4. Let's make this, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those. So we're going to go from here and we're going to go and do that. Okay. Now I'm going to just put one more of these. And I'm going to say 15. Let's see what happens. Oh, I didn't change it. Now that time was on me. Okay, did I save it? Control save, I sure did. Okay, notice because I used a long float, I have even zeros, okay? If you don't use enough bits and you force a precision, you're going to start to see stray numbers come out in here, okay? And the reason for that is you don't have enough bits to support the precision. So let's try just making this a double. We're now in complete experimenting live as I do a video. Let's see what happens. Oh, look at that, because I changed it and it's not a long float again. All right, so I have to change this now to a double, so that's just floating point. Which makes sense. Let's try it again. And honestly, I like to play around with this because I like to see the different types of generations. Now, in that case, it held it. Okay, it really still held for that number. So I'm still trying to do some numerical research on this. Let's try to make this. Oh no, that's because I had the zeros. I'm sorry. 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5. Let's put some precision out there. I actually had to do some work on this when I was in college. It was a course I did for both my math and my computer science, and I was exploring the entry of errors. Okay, 0, 1, 2, 3, 4, 5, 0. So it seems to be holding pretty well because it gets to the 5 and puts a 0. So let's make this 25. And I'm going to push it out to 25. And I should change this while I'm at it. So we're going to really push this envelope. And I'm going to try to force some mistakes. And I'll be impressed if it holds. Ah, there we go. Okay. The number only goes to here. That's the number. But look at this. It goes 2 more zeros. Now I'm getting garbage. Okay? It's just not precise enough anymore. So there's error in my number. Okay? And that's what I'm talking about when I say you've got to have enough bits. Otherwise, it's just going to get confused. Okay? It doesn't have enough bits to store enough precision when I downgraded the amount of bits I had available by making this a double. Okay? So I'm not going to drive it any further than that. Just be very careful that you have big enough variables. And one of the ways you can kind of test that is with your print statements. You can force precision way out there and begin to see, when it starts to break. It's if you're into math and you really enjoy the binary stuff, it's kind of cool to begin to see where your numbers start to break down, especially if this is going to be involved with an algorithm for a self-driving car, a drone that's going to fly people around as a taxi cab, or an upgrade to a Patriot missile battery, as we've talked about in IDT. All right, so that's it for this program. And in the next one, we're going to start beginning to deal with selection. So we'll see you over there. Welcome back. Hopefully now you have a better grip on how to print in C. Printf can be a little tricky at first, but I encourage you to keep playing along with it and playing around with it and just learn more by doing. Printing is something that the more you do, the more it becomes second nature and you won't even think about it when you go back to it. What we're going to talk about next is the second pillar of computer programming known as selection. So I'll see you on the other side.